It's working. Okay. Now I would like to graph it. Okay. I start with the center. And the center of this circle is at -4, 3. 1, 2, 3, 4, 1, 2, 3, right here. The radius is 4. So here's what I do. If you'd like to watch for a second, I plot the center, and I measure 4 units this way, going west, north, east, and south, and create 4 points. 4 units away. Why? Because that's the radius. So here's 4. Here's 4. 1, 2, 3, 4. Here's 4. 1, 2, 3, 4. Of course, my circle is not going to be perfect, but you get the idea. This is the graph of the circle with a center -4, 3 and a radius of 4. Any questions? The second type of problem is give me a center and give me a radius. Let's say 4, 0. And give me a radius. 6 indeed. Okay? So I would like you to determine the equation of the circle passing through, having the center like 4, 0 and the radius of 6. I'm ready when you are.
1, y.
I cannot start with y. Yes?
Plus -1.
Very good.
Plus square.
I'm not, exactly. Plus,
Y
yes? Which is y?
-0.
Which is y?
Squared.
That's it. This is the equation of the circle with a center 4, 0 and a radius of 6. Let's graph it. Four, 0. 1, 2, 3, 4, 0. Now I go north, south, east, west. How many? Indeed. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the equation of the circle. And this is the graph of the circle with a center 4, 0 and a radius of 6. You made it up. Any questions? Any questions? Now I want to look at the last type, and I cannot make that up. I have to pick a problem. Or you pick a problem. From 53 through 64. Any problem you would like on page 332? Which one?
61.
They reserve the odd number ones so you can do them and check the answer in the back. Choose any even. 60. Very good. So let's copy 60. X squared plus y squared minus 6y minus 7 equals 0. I would like to write the equation that I would like to see after different steps. What equation do I have to see? Please dictate. You don't know anything about numbers, but what am I trying to find or show? X minus. Very good, awesome.
Squared.
Yes, plus.
Y minus. Y plus.
They're all minus.
Okay, the both minus.
Equals? No? Yes. So, through a sequence of steps, I'm hoping that I can make this look like this. So let's analyze what we see first of all. So when I expand this, we sign the contract. When I expand this, how many terms do I get?
4.
One more time. She does that intentionally. So x minus h squared, how many terms? One with x squared, the other one with x. Yes, you're right. X and some free term. Okay, let's see here if I have x squared. Do I have a term with x? No. So then that is this. Good. Now I'm here, plus. When I expand y minus k squared, no, I don't get 4 terms, but I get, good. I get a term for sure with, and a term for sure with, and some free term. Now, do I have the first 2 terms here? Look at the middle coefficient. -6 divided by 2. -3 squared. Good. So I have plus y squared minus 6y plus 9, 7 plus 9. So I had to add 9 to both sides, and of course I moved 7 to the other side. What do I do with this?
So are we just complete the square?
Exactly.
Okay.
Absolutely. I wanted you to say it. So x squared stays. What about this? I have to. Very good. Everything squared. Equals? That's why we signed the contract. So I don't have to come back to it. Equals 16. So I rearrange this like this. I'm asking you now, is that for sure an equation of a circle? What is the center?
0, 3.
Careful.
0, 3.
0, 3. What is the radius?
4.
Awesome. So center, 0, 3, radius 4. Let's graph it. And let's choose another, please. Choose another problem. Let's work on it. So here is, I just did trig with the other class, and I used the unit circle 15 million times, and sorry about that. Okay, center, 0, 3. 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the equation of the circle. This is the graph of the circle with the equation x squared plus y minus 3 squared equals 16. So please give me any other equation between 53 and 64. 62. Let's copy 62. X squared plus y squared plus x plus y. I should have never allowed him to pick. Minus 1/2 equals 0. I know. Antoine did the same thing. But at least he had the decency not to pick a problem with fractions. Never mind, I'm kidding. Okay, so let's look at this. What do we want to do with it? We want to change it eventually into, and I want to write it. Yeah. Very good. Squared plus. Perfect. So if this is a circle, if this equation is the equation of a circle, I should be able to arrange it like this. Okay, so I go back to the original equation, and where do I look? First, I look at x squared. What else? The other x. And think. What is the middle coefficient? Divided by 2. 1/2. Square 1/2. 1/2 times 1/2. Very good. Carefully, remember we have to add to both sides. Now I would like you to tell me this, because we have an agreement, this and this, what do they form? And I will write it. X, say it again.
X minus 1/2 squared. X squared.
I cannot put minus if the middle coefficient is positive.
Plus 1/2 squared.
Awesome. Thank you. Good. Now I would like you to look at y squared and y and tell me what I have to add to both sides. It's the same thing. It's exactly the same thing. So now this and this and this are here. Here where?
Plus 1/2.
That's it. So let's see what's left. This is left, and I have to move 1/2 to the other side. 50 cents plus a quarter plus a quarter. I need the center now, and I need the radius. Very good, awesome. And the radius. That's it. The square root of 1 is 1. Any questions from me? Any questions? Any questions? This is the end of chapter 2. Now you can say, I need another example of this or another example of that, and I'll do that. If not, I would like to review the quadratic functions with you, which is section 3.1. But I want you to decide. Yes, of this? Okay, very good. Can anyone choose, please, between 50, what was that, 50? So between 53 and 64. Now, what if I choose this time? That does it. 56. 56. X squared plus y squared minus 4x minus 12y minus 9 equals 0. If this represents the equation of a circle, if, I don't know yet, what should I get?
X minus 3
Very good. Yes?
plus y minus 3
Yes.
equals r.
Right. So only the the fact that we wrote it 4 times, now it kind of, got embedded in our system. Good. So let's look at the equation. What will you tell me to do?
Four divided by 2 squared, so 4.
Excellent. As long as we don't forget to add to both sides. Is that okay?
Can you explain more how you got that?
The middle coefficient divided by 2 and I square it.
Okay.
It's the contract that we had from the first day of classes. A minus B or A plus B, everything squared is A squared minus 2AB plus B squared. And this is completing the square.
Okay.
The middle coefficient divided by 2, square the answer and add the answer to both sides.
Okay.
So then we have complete the square for x. Can anyone tell us what to write? Very good. X minus 2 squared, because we know that x minus 2 squared is x squared minus 4x plus 4. That's why I said this from the beginning, so we don't have to go back, and if we cannot find the time soon to look at those 3 special products in the contract, Then you will always hit a wall. Plus I have to show what I add, but you're right.
Plus 36.
Exactly. The middle coefficient divided by 2 is -6. -6 squared is 36. That's what I have to add to both sides. So what do I get now in blue? 1 minus 6, indeed, everything. Good. Now here's what is left. This is left, this is left, and this is left. And they all have to be on one side. Awesome. Is this the equation of a circle? If it is the equation of the circle, I have to be able to identify the center and the radius.
2, 6.
Do we all agree with 2, 6 for the center? And the radius? That's it. Do we feel a little bit better about this? The only thing is that we have to complete the square in 2 situations out of 3 that we looked at for 2 different variables. That's all it means. This is why complete the square is important, not for solving quadratic equations. If you remember, complete the square in a quadratic equation didn't solve the problem. We had to use taking square roots. But we learned this for this specifically. Any questions? Any questions? Okay. So I'd like to review with you 3.1. Quadratic functions. So this is part of chapter 3, and I should have written, so this chapter 3. Chapter 3 is a big thing. It deals with quadratic functions. It deals with polynomial, and you can say, but what about quadratic? Isn't that polynomial? Yes, but we mean higher degree when we say polynomial. Polynomial functions and rational functions. So what are we going to look in this chapter? What are we going to look for? We're going to look at those graphs. We're going to graph all of them. Quadratic, different types of polynomial, and rational. And then we look at applications. They have multiple applications. Okay, so let's start with reviewing everything about quadratic functions. In transformations, we already know. What is the simplest possible quadratic function? X squared. We know that, right? From transformations. Good. So a quadratic function can be given to us in 2 different ways. It's the same thing, but you'll tell me what is the difference between these 2 ways of giving. I can give you a quadratic function in 2 different ways, but it means the same thing. This is not the h and the k from the circle. We like to use h and k. That's all it means. It has nothing to do with what we did in the circle. Okay, can anyone explain what's the difference between these 2 forms? It's going to be the same function. It's going to be graphed the same way. We're going to go through the same steps. But what is different here? The second one, yes?
The one on top is the second one, like distributed all the way around.
Okay, very good. So what can you say about this one compared to that?
It's vector.
Or we just used it. We just used it 5 minutes ago, 2 minutes ago. Completed the square. That's exactly what it is. So they are the same, but this one has completed the square. But it's the same. Exactly what you said.
Why don't they have different letters? Yeah, one has C, one has K.
Very good question. Because B and C will not be these 2. So we have to give them a different name. They will not be the same if you have to complete the square, right? So look at this. Very good question, actually. But if I have, for example, x squared plus 4x plus 6 is this. But if I complete the square, I get x squared plus 4x plus 4 plus 2, which is x plus 2 squared plus 2. So they cannot be the same. This is 4, this is C, this is H, this is K. Very good question. Very good question. Right? So what did I do here? Middle coefficient divided by 2, and I squared it. So I had to split. I split 6 into 4 and 2. I combined these 3 into x plus 2 squared, and then 2 was left. If I expand this and add 2, I get this back.
The second had to
4 divided by 2 squared is 4. So I had to split 6 into 4 and 2. I only needed a 4 for these two.
That's not completing a square. So
This is complete the square, but it's not an equation. So yes, or you can add and subtract. So if you don't even want to look at this one, then you have x squared plus 4x plus 4 minus 4 plus 6. This has to be 0, bless you. This has to be 0, otherwise you change the problem. And then you combine these into x plus 2 squared, and this is your positive 2. Or you think in terms of splitting 6 into what you need for these two and the rest. I needed a 4, so I can split 6 into 4 plus 2. Now this portion is x plus 2 squared, and this one is stays. Or you say I'm adding and subtracting 4, which is adding 0.
So instead of adding 4 to both sides,
There is no,
subtract it from
I
the
have
side.
to do this because there is no other side. This is
So you
not
just
an
subtract it
equation.
from the same side.
Yes,
it's
exactly.
not equal to 0.
Exactly. I'm adding 0 in the form of 4 minus 4.
Okay.
Adding 0 doesn't change anything. Yes. So that's why A is the leading coefficient, which is the same, but B and C cannot be the same, right? We had 4 and 6, and this is 2 and 2. But it's a very good question. Good. So now we identify that this is the expanded form, and this is the one with a completed square. Awesome. I claim that here A, B, and C are real numbers, but A cannot be 0. Why?
You can't factor this with stuff.
If this is 0, this is what happens. Right, so it becomes linear, exactly. That's why B and C can be 0, but A cannot be 0. Because if A is 0, the whole thing changes from a quadratic to a linear. Very good. Good. So let's graph a quadratic function. And no, I'm not going to ask you to give me a quadratic function. I'm going to pick it. Here, who knows what you come up with? I'm kidding. X squared plus 6x plus 8. Is this quadratic? Yes, it's quadratic. First step, shape. We know that a quadratic function either looks like this or looks like this. But from transformations, we know that it looks like this when the leading coefficient is awesome. And it looks like this when the leading coefficient is correct. So which case is ours? Very good. So when the leading coefficient is positive, we already know from transformations. When the leading coefficient is negative, we already know from transformations. So now, this one, this point and this point, both of them are called vertex, plural vertices. Only the quadratic function has a vertex. No other function has a vertex. And this in this case is a minimum. And this one in this case represents, very good. Step number 2. The vertex. anyone remember how do we determine the x coordinate of the vertex? It's okay if you don't. I want to go back to the quadratic formula. Can anyone give us the quadratic formula for a x squared plus bx plus c equals 0? Can anyone dictate the quadratic formula? X equals negative b plus or minus the x coordinate of the vertex. Oh, I'm sorry. Is this. If you remember the quadratic formula, you should have no difficulties remembering the x coordinate of the vertex. Okay, so let's go back. I want to determine negative b over 2a. Negative is outside. What is b? And remember, this has to be in descending order, otherwise I will not identify a, b, and c correctly. Always remember that, bless you. What is b? I know you said 1, so I'm sorry, forgive me. Over 2 times a. Good, so the answer is? Good. So the vertex has the x coordinate negative 3. How do I find the y coordinate of this point?
Y equals a times x plus h squared plus k.
Right, of course. This must be f of negative b over 2a. No discussion there. This must be f of negative 3. There is absolutely no discussion, right? If for a function I have the x value, how do I determine the y value? Exactly. Very good. So f of negative 3 squared, plus 6 times negative 3, and plus 8. Where do I start? Yes, what do I get? Then? Awesome. Very good. And the answer is? Well, this is 17 and this is negative 18. Negative 1. We agree with the vertex negative 3, negative 1? Okay, perfect. Step number 3. X-intercept. And I'm going to write comma if they exist. I don't want to waste my time. So there are 3 possibilities here for a minimum, right? So imagine the minimum, because it has a minimum, right? It can cross the x-axis twice. It can barely touch the x-axis, or it can be way up there. Let me show you the 3 possibilities. So it can do this. It can do this. And it can do this.
That's the first one.
How do I know it's the first one?
Just put the points in the vertex are negative.
Because the y-coordinate of the vertex is negative. Exactly. So the y-coordinate of the vertex is a negative number. This is not a negative number. How much is this? 0. How much is this? Not a negative number. Positive. So it must be this. Very good. So then, so is that okay?
I missed that. All right, there we go. All right, thank you.
Is it okay?
Yeah.
Very good. So how do I determine the x-intercepts? I know they exist. I know they are 2 distinct. Yes. Marcus, you wanted to say that? Indeed, y equals 0. So then I have x squared plus 6x plus 8 equals 0. What type of equation is this? Of course. There was a little trap there. Good, you didn't fall in it. And how do I solve it? I know 4 methods. Which one? Never. I will never complete the square.
You just taught us to complete the square.
No, I never did that.
He's half of the circle.
Never mind. Don't mind him. So he's trouble tonight. So, exactly. So how do I factor? Yes, Shannon?
Plus 4 and x plus 2.
Awesome. So there are 2 options, x equals. Yes? So what are the ordered pairs then? Very good. The y-intercept always exists. Y-intercept. How do I determine the y-intercept for this function or any function? Awesome. So I have to find f of 0. 0, 0. The steps will be mentioned. I will mention the steps for you. 8. So what is the ordered pair then? We haven't graphed the function, but we already imagine it. Can anyone give us the range? We always start from the lowest y value till the largest y value, and since I'm showing this, it cannot be negative infinity.
0 then negative.
Nope.
I mean 0.
No, negative.
Negative 1.
The minimum is negative 1 to infinity. So the range, negative 1 to infinity. I'm not going to ask you to find the range without graphing it, but since we already have it in our, yeah. Good. So 5 and 6 are words. The parabola is a symmetric graph. Well, I'm not talking about odd or even here. I'm talking about symmetric respect to the axis of symmetry. So axis of symmetry is, so if this is the parabola in our case, the axis of symmetry is the vertical line passing through the vertex. Our vertex is here. Can anyone identify the vertical line passing through the vertex? X equals negative 3. Very good. It's the vertical line, x equals negative 3. We will graph the axis of symmetry, but not as a solid line. And the last thing here is, what does this function have, a max or a min? Minimum. So min value of f of x is, that's the reason I asked the range first. Indeed. This is it. So let's graph this function. We start with the vertex. Can anyone give us the vertex? It was negative 3 comma negative 1, correct? Very good, thank you. After I plot the vertex, I draw the axis of symmetry, which is not a solid line. It will only help me keep the graph in shape, symmetric with respect to this line. So this is x equals negative 3. Please give me the x-intercepts next. Very good. Negative 4, negative 2. Look at this for a moment. These two have to be symmetric. They have to be at exactly the same distance from the axis of symmetry. If I have 1 unit here, I have to have 1 unit here. And please give me the y-intercept now. Awesome. When I graph the graph of the parabola, remember, we have to graph it as smooth as possible, not acute at the vertex. I'm not going to look at it with a magnifying glass, but we have to keep it in shape. So this is the graph of f of x equals x squared plus 6x plus 8. There are tons of applications with quadratic functions. Can find one that we can finish in a couple of minutes, and I still want to give you some work. I have some work for you today. So here's where we are. So I still have to show you from this section some word problems. And I still have to show you how to handle the other form with a completed square, which is the same. Okay, but it will be easier to identify the vertex. So this is not completed. Okay, so I'm going to stop here for tonight, and I'm going to give you the classwork. So next week we're going to make headway with 3.1 and 3.2. Next week is the last week before the spring break, and